So very good afternoon to all. So we are dealing in unit number 1 in smart sensor and application, and the unit number 1 is introduction to smart sensors, in which we are in part 2, session 2. Okay, so today we will discuss about the evolution of smart sensor. So how this smart sensor has evaluated. Okay, so an introduction about this evolution is we should all know that anything which has been developed is initially used in only military, then only it comes to commercial purpose. So similar way, the smart sensors technique also was developed in late 70s when processing capability and based on readout integrated with single processing. When you say smart, something should be recorded, and then from the recorded information you have to go through. So after 1970s, when the processing is capability has come, then they started this smart sensor methods in your military applications. Okay, then smart sensor technology was kept restricted within the closed military environment from 70 till 90. It has only been used by militaries. Okay, see, anything in military will be kept only close, because okay, I think you all know plaster of Paris, you all know that we say when there is any fracture, we try to apply this plaster of Paris, and then after 15 or 20 days, once your bone join, they will remove. But the source of this plaster of Paris is not for fracture. It was used in military aircraft. Okay, so in aircraft there is a problem is outside temperature will be minus, inside you have to be in a particular temperature, and when the sunlight falls on the aeroplane, then the surface of the aeroplane will get heated to some around 45 degree to 50 degree. So this outside heavy temperature should not affect the pilot, so he has to be protected. So a layer of plaster of Paris is coated between the two levels of metal, so one outer metal, one inner metal. So between these two layers, plaster of Paris is coated. Okay, similar way, everything is initially it is developed only for army. So once you develop for army, they will keep it close, because they will not allow it to known to others, because this will be used by other country also. So that is why even smart sensor technology was kept restricted within close military environment, exploring the application performance, and in 19 only it has been given to public. Okay, the integrated signal readout and processing achieved by CCD CMOS technology in FPA, field programming array. So all this you might have known, field array programming. So till that instant it was used only in military. Then the rapid advancement of VLSI. VLSI is very large scale integration. See, whenever you say smart sensor should have a sensor, then signal conditioning and microprocessor. So here, if all is brought into a single IC only, then you can say there are so many advantages. So after the invention of technology called VLSI, very large scale integration processor technology, and EO detector array technology allowed to develop new generation of smart sensor. So from the generation 1, 2, 3, from generation 1, 2, we cannot call it as a fully smart sensor. Only after this VLSI is from the generation 4 and 5, they say it is a Pakka smart sensor technology. Okay, so VLSI plays a major role. The new and the future technology of nanotechnology, bioorganic electronics, biocomputing. So all this thing, once it has come, smart sensor grow up. Okay, so it has come into all field. Okay, and then the main domain, which is space-time domain, to spectroscopy, which is absorption of the emission of light. So after the nanotechnology methods, we were able to identify some crystals which are able to observe your light source and try to give. I think you all have a video game at home nowadays. That will sense the light and all. So light, colors and all, it has been sensed, and you play the game. So you have to think how that is happening. Okay, that is because of there are some materials which observe light of, and they will try to give it as in terms of electrons. Based upon the light color, the emission of electron also will change. Okay, So after that spectroscopic of space domain, that is absorption and emission of light, the smart sensor has become wide. So I think you all know, even now robots are there, you can identify the colors which is kept before the robot. Okay, so now that has been done with the smart sensors, and that smart sensors are light sensing devices, so they are able to sense the VIBGYOR, all colors. Okay, so they will try to observe and give it in the form of electron or voltage or current usage. So that is possible only with the help of nanotechnology. So these were the various developments in your smart sensor. So basically I say it as smart sensor started in the year 1970. Until 1990 it was with the military. Then after 1990 it has emerged into the public. Once it has emerged, and with the development in technology of VLSI, it played a major role with some nanotechnology and bioorganic electrics. All this bioorganic electronics is nothing but there are some crystals. That crystals, when receives in a particular color, even specifically I am saying a particular color, it will try to generate electrons. So from that we are able to identify the variation in colors. Okay, whatever may be, just I am to caution that nothing can touch the nature. So as we are able to see the difference in colors, that we are trying to do. Okay, next. So evolution, when you take sensor, also come up through different stages of upgradation. So it has started, then it has gone through so many stages of upgradation, and then final stage has come. The final stage we call it as fifth generation smart sensors. Okay, so started with the first generation, then they move on with second generation, and then third generation, then fourth and fifth generation. So let us see first generation. So in first generation it is a beginning stage of sensor. So in the beginning stage, device made of limited electronics with MEMS that we have seen last class, micro electrical and electronics combination, mechanical electrical combination sensor element. Why we say mechanical is well-known sensor is we call it as piezoelectric crystals. So in piezoelectric crystal, when you apply vibrations, you will get electrons. So that vibration is in the form of mechanical. Okay, so first generation was converting mechanical to electrical. So that is what they were able to do. They were able to convert the mechanical to electrical. But nowadays I have told you, we have now even for a conversion of light to electrical signal. Okay, so MEMS means micro electromechanical system, sometimes known as microelectronics and microelectronical system. So MEMS are made up of component size between, see, the thickness of piezoelectric crystals are not so thick, it is very thin, then only it can make the vibration to convert into electrical. Okay, so MEMS are made up of component size between 1 to 100 micron meters. Okay, so very thin, and MS based device sizes ranges from 20 micron to 1 millimeter. So maximum thickness is 1 millimeter, so minimum is 20 micrometers. Okay, this is about that first generation. In second generation of sensors are MEMS sensor element along with analog signal amplifier and analog to digital conversion. So first thing, they don't have inbuilt conversion and all. They give the raw piezoelectric crystal, they call it as sensor. When you give a mechanical input, it gives electronics output. Okay, that's all. Then from that, all other process has done externally. Whenever you say externally, there will be some loss. Okay, see, for example, I am giving something you to on your hand, and if I ask you to pass it to the next and next, obviously let us assume I am giving some food item. What you will do, you will try to taste something and then you will pass on, and finally it will reach, nothing will be there. Okay, so that is why, or even one more example I can give you. I can ask you to walk. Okay, so you will walk from here, from our college to Kamachi hospital without any issue. If I have asked you to walk till Pallavaram, okay, around 80 students, around 40 students will try to reach, and the remaining they get tired. Okay, now if I ask you to go to Tambaram, then it will become very difficult. So what is required is amplification is required. In terms of signal, we call it as amplification. In our case, we call it as a public transport like bus, which is run by a driver. That is why the name came for that particular person as a driver. See, why you call it as a driver? He is driving us. That is why the name driver came there for your a person who is going to drive the bus or any transport. Okay, so when in our example we say driver is driving a bus. Okay, you will all get into the bus and you till what distance you want to travel, you will travel and come down. Similar case, in first generation what they did is they use the sensor and the output will come. They add this amplifier outside the sensor, so some amount will be lost, then amplification will be done, then they will do the remaining process. Whereas in second generation what they taught, okay, why can't we place this amplifier and the analog to digital converter in a chip itself? Okay, so sensor followed by amplifier followed by analog to digital will be there inside a single chip itself. So you can directly go buy a chip. That chip, what it will do, it will have a ventilation like open structure where to sense it. Okay, it will sense within that IC itself with the gold or silver line. We know all ICs are made up of gold and silver lines inside. All the tracks, all the signal passing will be on gold and silver, because we all know gold and silver are very good conductors. Okay, compared to other type of material, only gold is a very good conductor without any loss. Other persons are also conductor, but you will have a loss. So in second generation, keep it in mind, first generation only sensor, all other thing are externally you used it. In second generation, they thought that there are some loss when there is travel externally, so don't allow to travel externally. Take the sensor, then followed by an amplifier, followed by an analog to digital converter are there in a single chip itself. So this is what is the second generation is. Okay, then in third generation, sensor include MEMS element, analog amplifier, analog to digital conversion with digital intelligence. So this word intelligence come into picture for linearization and temperature compensation. So linearization is there may be some noise also picked up by your sensor. So if you have a sensor, what we are saying, sensor is going to get the information. So mechanical to electrical or light to your electrical, final we say electrical, and this electrical what is coming from the sensor will be analog in nature. Analog has to be converted into digital, because we all know we use only digital system in computers. So all your process are done in digital. So what they did is from the sensor you get an analog, and that analog will be so weak, try to do amplification, so the signal level will be increased and then convert it the analog to digital. Till that what we have done in the second generation itself. In third generation, I have an inbuilt memory saying that okay, what I am getting as digital data has some error also, so try to remove that error and try to get pure signal. I will like to give an example here. So when you take signal from brain, okay, like ECG or anything, they will put a sensor on brain and try to get the signal. From that signal they will try to tell what is the problem with that particular person. In that case and all, your brain has more than 1 lakh signals. Okay, so from that 1 lakh signals I have to identify what the signal which I want. Okay, so for the movement of eye, for the movement of hand, for the movement of legs, and for the each and every part movement, the signal has to come from brain. So that signal also I can tap, but that signal will have all the unwanted signals also. If I want to tap a particular, the remaining has to be not to be observed. Okay, so in that case I should go with the digital intelligence. Okay, so that is for third generation. So I think you all clear what is first generation, what is second generation, what is third generation. Then for in a third generation, so what and all you have done, you have a transducer. Okay, transducer is nothing but a sensor followed by a signal condition. You have an ADC. After this ADC you have a microcomputer. Okay, so all this are put together in a single unit. So okay, for this computer, small processor See, when you say microcomputer, it is nothing but a microprocessor. So it is a smaller version of your laptop or system. So okay, so that will have an RAM. RAM is nothing but memory. See, whenever you compare any man-made inventions with nature, that is unpredictable. Okay, see, let us assume our level of understanding is very different from system. Okay, you might have studied with a particular person in first standard or second standard. Even now, if you see him on the road, your brain will identify and tell. You might have seen him with an height of 2 meters or 1.5 meter at the age when you both were studied LKG or UKG. But he has also grown for 20 years and you are also grown for 20 years. But your brain has a capability of, as you might have seen him only at the age of 5 to 6. But now when you see him, your brain automatically correlated with the common terms which was there in the age of 6 and then it will try to reproduce. But to that level we try to do, but that is not possible in case of system. Okay, so signal is coming. So from the signal coming, with my own experience, I will say among this is signal and remaining is not required, so I can separate. For that I have a RAM. So that is what done in third generation level. In third generation level, you add a signal, do the signal conditioning, then you do analog to digital conversion, then I am able to identify whether that is noise or signal, how I am doing with my past experience. Okay, past experience I have stored in RAM. I will say if this is EEG, this should be the shape, omit all other waves. See, if you are capturing this is EMG, then this is the signal, omit the remaining part. So like that some content is stored, but this is not as accurate as human, but accurate to some extent. Okay, so this is called third generation. And fourth generation, in fourth generation what we are doing is a memory cell for calibration and temperature compensation data are added to the element of the third MES sensor generation. So from third, this is an additional memory adding. Okay, so some amount of memory we are adding, and that memory we are able to do process at a better rate. So even this I like to tell an example. They say human started when you say we have started from like they call it as orarivu 2 3 4 5, and then we say now we are in orarivu we have, then you can have a doubt. Okay sir, till animals you have told, from monkey we came, what about sir after monkey we came? So after is there is no, the answer is till that instant you require change in your physical. Okay, so once you reach as a human, there is no need to for change in physical appearance. You have standard, you are able to stand with 2 legs, you had a good hand to do all the work, your all structures is pakka. So after that what is happening is it is a development in brain. Okay, so even when you see a child born on 1980s, when you compare with a child born on 2000, at the age of 2, at the age of 3 so itself, the child is able to handle the cell phone. That also you can see at home. So when you compare with your age, with your father age, and your relative newborn baby of age 3, so even you can see I have completed my 12th in 2000. At the time you have not born. Okay, so I can, even we too can have a good comparison. So your age now you might be around 18 or 19 or 20. Okay, so now within our age gap itself we are able to see the development now is in terms of memory. A similar way only the third and fourth generation. So from the third generation to the fourth generation, it was development in memory. So that you have to remember. For that only I have told this all stories. So story apart. So from the third generation to the fourth generation is with respect to memory development. Okay, so fifth generation we can call it as a final end, or we have achieved a pakka in smart sensor. So there are several technology involved in making this smart sensor. So MEMS and VLSI we have already seen. So micro electromechanical system is combined with very large scale integration technology. So everything is brought under a single IC. So that is the final. in 5th generation. So now there is no difficulty. You can directly go to shop, get a, say I want to sense light, I want to sense a particular wavelength, then ICs are directly available. Okay, so VLSI is the process of manufacturing of a computer chip and implanting large number of transistor gates on a single semiconductor wafer. This technology helps in reducing the size of the circuit and cost of the device and increasing the speed. See, when the communication is between the IC itself, it will be very speed and less power consumption, and the power consumption plays a major role. Okay, see, you are launching a satellite, okay, satellite from the ground to the space. So when you launch the satellite, satellite required powers, and then I cannot put big battery to my satellite so that it can supply the satellite. So with the minimum power we are supposed to operate. So when you want the minimum power, then you go for a smart sensor with VLSI and MEMS technology. So power consumption will come down. All these sensors are able to sense and process atmospheric data and able to communicate with data center wirelessly. So now when you see the example for satellite, so from satellite we are able to get all the informations like weather, so weather forecasting we can do, then the aerial view we can do. From there itself you can screenshot it. All the example is Google. Okay, when you see Google map, we are able to see how it has been done. The data is been from the satellite, and your data is sent wirelessly from your satellite. Okay, for your information, now you have placed a geostationary satellite around the earth, and there are around 32 geostationary satellites we have placed. Okay, so from that 32 geostationary satellite, we can point any one vehicle even driving on Mount Road. So even I can read the number plate of the car from that geostationary satellite. So at an instant, for say instant, any one particular place that is been viewed by 3 satellite or 4 satellite. Maximum of 4 satellite we will try to view at a particular portion. So that is how what is the technology which has been developed. So in 5th generation, everything is brought under a single roof or a single IC. You will have a transducer, you will have a PROM. PROM is nothing but programmable read-only memory. Programmable means at one shot you can write the program, then it will become read-only memory. Then comes your ADC, then a small computer itself is placed inside your smart sensor itself. Okay, then this output will communicate with the external computer, and that computer will execute with the wireless communication. So what are the advantages of smart sensor? Minimum interconnecting cables, because you don't want interconnecting cables at all, because everything is brought under a single IC. Then highly reliable. See, only if you have soldered and made a board, then there is a chance for desolder or cut off wire, but when it is there inside a single IC, it is more reliable. Performance is very high performance, then easy to design, use and maintenance, scalable, small rigid packet, minimum cost. When brought inside a single IC, obviously the cost will be less. Then let us see various application of smart sensor. The first one is accelerometer. You might have come across this. Okay, this is a very smart sensor. With this smart sensor, I can identify the acceleration. So it is there nowadays in the mobile. So we are able to see what is the distance travel, what is the speed in which we travel. Similarly, you can even record it in your vehicle. So you can even track your vehicle, where your vehicle is going. So it has an inbuilt IC, a single IC with an antenna, so that will transfer the data wirelessly. Okay, so this is one best example of smart sensor. Then comes your optical sensor. I have told no, in the front we will keep that nanocrystalline material, so that crystalline will be able to measure the light. Okay, so optical sensor is one of the example of smart sensor which are used for measuring the exposure of camera, optical angle encoder and optical arrays. A similar example are load cells of silica based pressure sensor also. Then comes infrared reductor. So this also you might have seen some in 5-star hotels and all, where if you try to open the door, then only the lights will be turned on. So lights will not be put to on continuously, so it is a wastage of power. So in order to reduce the wastage of power, what they do is they measure the infrared. Okay, for all humans has some you have a temperature of around 98.3. so in a room, when a person enters, there is a temperature change. This IC will try to measure the temperature change. With that temperature change, it will identify that some object is coming in. So automatically with this help, you can try to turn on and turn off of the lights. Whenever the temperature is low, then we will say the person has gone out, you can switch off. And when suddenly if a person enters, when this you put out this type of sensor, it will measure the temperature variation and try to turn on. So with this this session we will try to stop. So if